Hi everyone, Assalamualaikum. In this video, we want to consider integration of cos ln 3x over x dx and integration of cos ln 3x dx, right? In this question, we have over x, okay? The question looks similar, but for left-hand side question, we have over x, and for right-hand side question, there is no over x here, alright? Alright, to integrate cos ln 3x over x dx, let's say we integrate by u substitution. And every time when we integrate using u substitution, we need to identify u. Alright, let's say we choose u equals to ln 3x, okay? And when we differentiate using u substitution, we need to differentiate u with respect to x. So we get du over dx equals to, we differentiate ln 3x, it is equals to 1 over 3x, and then times, we differentiate 3x, so we get 3. And after that, we can simplify 3 here and 3 in denominator, so we get 1 over x. And then we need to write dx as a subject, so we just cross multiply, so we get dx times 1 equals to dx, and x times du equals to x du, right? No more 3 because we simplify 3 here and 3 in denominator, right? And after that, we substitute back into the given question. So we have integration of cos, we replace ln 3x equals to u, and then we still have over x here, and then times, we replace dx equals to x du. And after that, we can simplify x here and x in denominator. So we get, right, after we simplify, so we get integration of cos u du, no more variable x, okay? Means that we success use u substitution, okay? So from here, we can integrate, right? And we have direct formula for this question. From integration of cos x dx, it is equals to positive sin x dx, sin x plus c. So when we integrate cos u du, it is equals to sin u plus c, right? And after that, the final step, we need to replace back u equals to ln 3x. So this is the final answer. When we integrate cos ln 3x over x dx, the answer equals to sin ln 3x plus c. And we integrate using u substitution, right? Alright, but let's say we want to integrate cos ln 3x dx. As I said before, the question looks similar, but there is no over x in this question. Let's say we want to use the same technique, okay? We choose u equals to ln 3x, okay? And after we choose u, we need to differentiate. And then we write dx as a subject, so we get x du. Okay, so our dx now equals to x du. And then when we rewrite in terms of u and du, so we get integration of cos u and then x du. Okay, from here we still have variable x here, and there is no over x here to simplify, right? So how to simplify x? Okay, in this case we cannot simplify x. Okay, so means that we can't use integration by u substitution, right? In this case, actually, we need to integrate using integration by parts. Okay, we will discuss later, right? So, for this question, we integrate by u substitution, and for this question, we integrate using integration by parts, right? Now we look at example 8. Evaluate integration of cos ln 3x dx. In the previous slide, we already discussed we cannot evaluate this question using u substitution, right? We also cannot evaluate this question using trigonometric substitution because there is no radical, right? There is no radical function containing a squared plus x squared, or a squared minus x squared, or x squared minus a squared. We also cannot integrate this question using partial fraction because there is no rational function containing polynomial in numerator and polynomial in denominator. Alright, so the best way, we need to evaluate this question using integration by parts. Alright, so to evaluate this question, right, when we integrate using integration by parts, we need to identify which function as u. And in this question, 3x inside ln and ln 3x inside cos means that we only have single question here, single function here. Okay, because cos and ln and 3x come together. Okay, so if we have only single function, so the single function confirm equals to u. Alright. Alright, so from here we have cos ln 3x equals to u and dx here equals to dv. Okay, and then note that dx always included in dv, right? And then we can rewrite, okay? In this case, we cannot use tabular integral, right? Why? We will discuss later, alright? Alright, from here, when we integrate using integration by parts formula, we rewrite, so we have integration of u dv. And then it is equals to uv minus integration of v du, right? And after that, we write u equals to cos ln 3x and dv equals to dx. Okay? From u, we need to find du to substitute into this formula, and we need to differentiate. From dv, we need to find v to substitute into this formula, and we need to integrate. Right? When we differentiate u with respect to x, so we get du over dx equals to, alright, since cos ln 3x come together, so we need to differentiate using composite function. So when we differentiate cos ln 3x, we get negative sin ln 3x. And after that, we differentiate ln 3x, we get 1 over 3x. And then we differentiate 3x, we get 3. And the operation in between must multiplication. And dx here come from over dx from left hand side. So when we write du as a subject, so we need to move over dx to right hand side. So we get times dx. Okay, we need to write du as a subject because we need to substitute into this formula. Right? And after that, we can simplify 3 here and 3 in denominator. So we get du equals to negative sin ln 3x and then over x and then dx. Alright? And from dv, we need to find v, means we need to integrate. Right? Or for quick method, we can close d for both sides. So after we close d for both sides, so we can see that v equals to x. Right? Or we just integrate both sides. We integrate dv, means we integrate 1 dv equals to v. And we integrate dx, means we integrate 1 dx equals to x. Okay, plus c, but no need to write plus c because we still not finish our solution. Right? And after that, we need to multiply u and v to substitute into this formula. And then we multiply v and du to substitute into this formula. Alright? And then we have u v equals to x ln 3x x cos ln 3x and then minus integration of x negative sin ln 3x over x dx. Right? Alright, we check one by one. U equals to cos ln 3x. Okay? And v equals to x. Okay, to avoid error, we put x in front here, right? Because if we put x beside ln 3x here, some student tends to multiply x and 3x. And actually, we cannot multiply x and 3x here because 3x here inside ln function, right? And ln 3x inside cos function. So to avoid error, we put single x here in front, right? And then we have minus sign, we have integration sign, v equals to x and du equals to negative sign ln 3x over x dx, right? After that, we can simplify x here and x in denominator. Okay, and then we have x cos ln 3x negative times negative equals to positive, and then integration of sine ln 3x dx, right? From the previous slide, we get integration of cos ln 3x dx equals to x cos ln 3x plus integration of sine ln 3x dx. Okay, so from here, we don't need to integrate because there is no integration sign. But for this term, we need to integrate because we have integration sign here, right? And to integrate sine ln 3x dx, again, we need to use integration by parts, okay? And when we use integration by part, we need to find the best function as u, okay? Since 3x come together with ln and ln 3x comes together with sine, means we only have single function. And when we have only single function, when we integrate using integration by parts, the single function is confirmed to be u, right? So this is our u, and our dx equals to dv, okay? And note, dx always included in dv, right? And after that, we have x cos ln 3x plus. We can rewrite this. So we have integration of u dv. And then we have x cos ln 3x plus. From this formula, we can use uv minus integration of v du. Alright, since we have positive symbol in front here, alright, so we don't need to put bracket. Right? But it's okay if you still want to put bracket, right? If the sign here is minus, so you must put bracket to avoid error, right? Alright, and then from here, our u equals to sine ln 3x, and then our dv equals to dx, right? And after that, from u, we need to find du. Okay, so we need to differentiate. And from dv, we need to find x. From dv, we need to find v. So we need to integrate, right? So when we differentiate u with respect to x, so we get du over dx equals to, we differentiate sine ln 3x, we have positive cos ln 3x, and after that, we differentiate ln 3x, we get 1 over 3x, and then we differentiate 3x, we get times 3. And then over dx here, we move to right hand side, so we get times dx. Okay, and then we can simplify constant 3 here and denominator 3 here. So we get du equals to cos ln 3x over x dx. Right? And then from dv, we need to find v, we need to integrate. Okay, or for quick method, we can just close d for both sides. So after we close d for both sides, we can see that v equals to x. Alright? Alright, after that, we multiply u and v to substitute into this formula, and we multiply v and du to substitute into this formula. So we have x cos ln 3x plus, after we substitute, we get this. Okay, we check one by one. Our u equals to sine ln 3x, v equals to x, and then we have minus sign, we have integration sign, v equals to x, and du equals to cos ln 3x over x dx, right? And after that, we can simplify x here and x in denominator here, and then we get x cos ln 3x plus x sin ln 3x minus integration of cos ln 3x dx. Right? Right, from the previous slide, we get integration of cos ln 3x dx equals to x cos ln 3x plus x sin ln 3x minus integration of cos ln 3x dx. For this term, we no need to integrate because there is no integration sign. But for this term, we need to integrate. Okay? To integrate cos ln 3x dx. Right? Is it we still need to integrate using by part method? Okay? If we still integrate using integration by parts, okay, we still use the same technique. Means we never stop our solution. Okay? So, what should we do? Okay? From here, okay, and from here, we have same term with left hand side. So we can move this term to left hand side. Okay. So after we move, so we get 1 cos ln 3x dx. This is minus sign. After we move, we get plus 1 integration of cos ln 3x dx. And then we still have x cos ln 3x plus x sin ln 3x in right hand side. Okay, and after that, since we have same term here, so we can add 1 plus 1 here. So we get 2 integration of cos ln 3x dx equals to, alright, we have x and x here. So we can factorize. So we have bracket cos ln 3x plus sin. No more x because we factorize x here. Okay, so we only have sin ln 3x. Okay. And after that, we want to evaluate integration of cos ln 3x dx. So we need to move 2 to right hand side. So after we move 2 to right hand side, so we get integration of cos ln 3x dx equals to half. And then we still have x here. And then times cos ln 3x plus sin ln 3x. And after we done all the integration, we can put plus c at the back. Right? So, this is the final answer. Okay, and we integrate cos ln 3x dx using integration by parts. And we use this formula. Right? Okay, we look back integration of cos ln 3x over x dx and integration of cos ln 3x dx. Okay. When we use integration by u substitution, for this question, we get the answer sin ln 3x plus c, right? And for this question, integration of cos ln 3x dx, when we integrate using integration by parts, we get the answer equals to half x times cos ln 3x plus sin ln 3x plus c, right? Let me check, is it this answer is correct or wrong, right? To check whether this answer is correct or wrong, we need to differentiate back, right? Because integration is an antiderivative, okay? So let's say we let the final answer equals to y. Okay, so now y equals to sin ln 3x plus c. Okay, so we differentiate, we get dy over dx equals to, we differentiate sin ln 3x, we differentiate using composite function. Okay, differentiate sin ln 3x equals to cos ln 3x, and then we differentiate ln 3x, we get 1 over 3x, and we differentiate 3x, we get 3, right? And in between must multiplication operation. Okay, in this question, we cannot differentiate using product rule because this is not a product function. Okay, but this is a composite function. Okay, So we need to differentiate using this technique. Alright. And after that, we have plus sign here, and then we differentiate constant equals to 0. Right? Then we can simplify 3 here and 3 in denominator here. So we get dy over dx equals to cos ln 3x over x. Okay? And when we compare with this function, it is equivalent. Okay, means when we differentiate back the final answer here, we get back the function that we integrate. Okay, means this is the correct answer. Right? Right, let me check this answer. Okay, in the previous slide, we integrate this question using integration by part, and we get this answer. Alright, to check whether this answer is correct or wrong, we let this answer equals to y. So now our y equals to half x bracket cos ln 3x plus sin 3x plus c. Alright. To differentiate half x times ln 3x plus cos ln 3x. Here, okay, we need to differentiate using product rule because we have multiplication operation here. Okay, so using product rule, we need to identify u and v. Okay, our u equals to half x and our v equals to cos ln 3x plus sin ln 3x. Okay, and then we need to find u prime and v prime. Okay, u prime equals to half and v prime, we differentiate this using composite rule. Okay, it is similar to when we differentiate sin ln 3x. Okay, so now we want to differentiate cos ln 3x equals to negative sin ln 3x times 1 over 3x times 3. Right? And then plus, now we want to differentiate sin ln 3x. Okay, it is equivalent to this function. So the answer also must equal to this function. Okay, so we have cos ln 3x times 1 over 3x times 3 after we differentiate sin ln 3x. And after that, we can simplify 3 here and 3 in denominator here. And we can simplify 3 here and 3 in denominator here. Then we get v prime equals to negative sin ln 3x and then over x. And then plus cos ln 3x and then over x. Alright? Alright, since now we differentiate using product rule, so we can cross multiply here v times u prime and u times v prime. So the formula when we use product rule, when we differentiate y with respect to x, so we get dy over dx equals to product rule formula vu prime plus uv prime. Right? And then we have dy over dx equals to our v equals to this function. Okay? And then u prime. Okay? U prime equals to half. So half times v or v times u prime. Okay? We get half times cos ln 3x and then plus and then half times sin ln 3x. And then in between is plus sign here for product rule formula. And then u times v prime. U here times v prime. So we have half x times negative sin ln 3x over x. We can simplify x here and x here. So we get half and then positive times negative equals to negative. And then sin ln 3x. No more over x here because we simplify x here and x here. Okay? And then half x times cos ln 3x over x. So we can simplify x here and x here. So we get positive half cos ln 3x. And after that, So we differentiate this, we get this, and after that we differentiate constant c equals to 0, right? And then we have positive half sine ln 3x and minus half sine ln 3x. So we can simplify this. So now we get positive half cos ln 3x plus half cos ln 3x. Okay, so we get dy over dx equals to half plus half equals to 1, and then cos ln 3x, right? So we check with the given function here, it is equivalent to this function. Okay, means that when we differentiate back the final answer, when we integrate, we get back the function that we integrate, right? So means that this answer is correct, right? So to integrate cos ln 3x over x dx, we need to integrate using U substitution. And to integrate cos ln 3x dx, we need to integrate using integration by parts, right? So that's the way how we check the final answer. We just differentiate back the final answer when we integrate. And if we get back the function that we integrate, means the answer that we get is correct, right? Right now, let's evaluate integration of cos ln 3x dx using tabular integrals under integration by parts, right? From integration of cos ln 3x dx, 3x is inside ln function and ln 3x is inside cos function. This is a composite function, means we only have one function here, alright? Under integration by parts, when we have only one function, so this is confirmed equals to u. Okay, so we can write cos ln 3x equals to u and dx equals to dv. Right? When we use tabular integral, we need to use table with 3 columns. Okay, the first column should be sine, the second column should be u, and the third column should be dv. In column u, we need to differentiate, while in column dv, we need to integrate. Okay, so now we have u equals to cos ln 3x. So we put here, and dv equals to dx. Okay, so we put here, right? And then let's finish column u first, so we know when we can stop the row, right? So from cos ln 3x, to differentiate cos ln 3x, let's say we have fx. Okay, we put fx equals to cos ln 3x. Okay, when we differentiate fx, we get f prime x, and then we differentiate cos ln 3x using composite rule, because this is a composite function. Okay, we cannot differentiate this function using product rule because this is not a multiplication function, right? So when we differentiate cos ln 3x, so we get negative sine ln 3x time, we differentiate ln 3x, we get 1 over 3x. Then we differentiate 3x, we get 3. Okay? And in between must multiplication operation, right? And after that, we can simplify 3 here and 3 in denominator. So we get f prime x equals to negative sine ln 3x over x. Okay? Then we put here, right? And after that, we need to differentiate negative sine ln 3x over x. Okay? Since we have fraction here, okay, and we have x in numerator and x in denominator, so we need to differentiate this function using quotient rule. Alright? So when we use quotient rule, we need to identify u and v, and we need to find u prime and v prime. Our u equals to the numerator equals to negative sine ln 3x. Okay? And then using this method, okay, when we differentiate u, so we get u prime, And then we differentiate negative sine ln 3x using this method. First, we get negative cos ln 3x, and then time. We differentiate ln 3x, we get 1 over 3x, and then times. We differentiate 3x, we get 3. And after that, we can simplify 3 here and 3 in denominator. So we get u prime equals to negative cos ln 3x over x. Right? And after that, from v equals to x, when we differentiate, we get v prime equals to 1. Okay? Right, from fx, let's say we put fx equals to negative sine ln 3x over x. Using quotient rule, f prime x equals to vu prime minus uv prime over v squared. Alright? So we get f prime x equals to, we multiply v and u prime. We can simplify x here and x in denominator here. So we get negative cos ln 3x. And then we multiply negative sine ln 3x times 1. We get negative sine ln 3x. And then we have minus sign here. So minus times minus equals to positive. So we get plus sine ln 3x. And then over v squared, v equals to x. And then we have x squared in denominator here. Okay, after that, we put here. Okay, negative cos ln 3x plus sine ln 3x over x squared. Alright. Now we get term containing cos ln 3x. Okay. So we can stop the row here. Okay. And then we finish column sign. Okay. We start with positive sign and then we alternate the sign. So positive, negative, and positive. Alright. And after that, we finish column dv. In column dv, we need to integrate. So we integrate dx means we integrate 1 dx. So we get x. Okay. And after that, we integrate x, we get x squared over 2. Right? Then, we can write integration of cos ln 3x dx equals to, we multiply this. Okay. And then, we have positive sign. No need to write in front here. And then, x cos ln 3x. We put x in front. Okay. Because we cannot multiply x and 3x here. Okay. So, to avoid error, we better put x in front. Okay. And after that, we multiply this and this. Okay. We have minus. Okay. And then negative sign ln 3x over x. And then we have x squared over 2. We put in front here. Okay. And after that, we multiply this, okay, in a row. Okay. For the last row, we multiply in horizontal. And we need to put integration sign and dx. Okay. We multiply this. We have plus sign. Okay. And then we put integration sign and dx. Okay. And we multiply x squared over 2 and negative cos ln 3x plus sine ln 3x over x squared. Right? And after that, we can simplify x squared here and x squared in denominator here. Right? Right. And then, we can write integration of cos ln 3x dx equals to x cos ln 3x. Negative times negative equals to positive. And then we can simplify x squared here and x in denominator here. So we only get x. Okay. And then sine ln 3x. Okay. And after that, we have plus sign here. And then since we simplify x squared and x squared here, so we only have half in front here. And half means time this fraction. Okay, so we can move out constant half from integration sign, and then we have negative cos ln 3x plus sine ln 3x. Alright? And after that, we can write integration of cos ln 3x dx equals to x cos ln 3x plus half x sine ln 3x. We split the integration. So we get half times negative equals to negative half integration of cos ln 3x dx, and then positive half times positive equals to positive half integration of sin ln 3x dx. Okay. So from here, we get term containing integration of cos ln 3x dx. We can simplify with the term in left-hand side here because we have same term. Okay. But how about term containing integration of sin ln 3x dx? Okay. Right from here, integration of sin ln 3x dx not the same term as left-hand side. So we cannot simplify this, right? So means that we can't use tabular integral to evaluate this question. Okay? Because actually this is a wrong method because we cannot simplify this. Right? So in this case, to evaluate integration of cos ln 3x dx using integration by part, we only can use integration by parts formula. And we cannot use tabular integral. Right? Got it? Up to this point, we done discuss all the examples under integration technique. Alright? So coming up next, we will discuss chapter 4, which is ordinary differential equation, ODE. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.